Good day, everyone. Here we are again to explain reflection on curved mirrors. I am teacher Jeffeline Mahinay Gingoni. Last video, we talked about on reflection of light. So you've learned that reflection is the bouncing of light when it hits on the surface. Now, today, we are going to determine the characteristics of the image formed on a curved mirrors. Okay? Our objectives are the following. Apply the principal rays in locating the image formation by concave mirror. Second, construct ray diagrams to determine the location, orientation, size, and type of images formed by concave mirror. Have you tried to look at your reflection in a shiny metal spoon? Is your reflection the same on the surfaces of the spoon? How will you compare your reflection on the two surfaces of the spoon? Alright, now a curved mirror is a reflecting surfaces in which each surface is a section of a sphere. The spoon itself is an example of a curved mirror. Now, there are two kinds of curved mirrors. Okay, this one and this one. Observe the reflection of the two curved mirrors. What can you say? Now, what do you call this mirror at the left side? Yes, it is convex mirror. How about this curved mirror at the right side? Okay, it is a concave mirror. What is concave mirror? Concave mirror, a curved mirror in which the reflective surface bulges away from the light source. So, kung baga, kaning curved mirror di ay hayang. So, the reflective surface is layo siya from the light source. Okay? Now, it is also called converging mirror because the parallel incident rays converge or meet or intersect at a focal point after reflection. And what about a convex mirror? Convex mirror is a curved mirror in which the reflective surface bulges towards the light source. So, nimpadong siya sa light source ang iyahang burot. It is also called diverging mirror because the parallel incident rays, as you can see on the illustration, diverge. What do you mean by diverge? Nakatag after the reflection. But when you are going to extend the reflected rays behind the mirror, look at the broken line behind the mirror, the rays converge at the focus behind the mirror. Okay? So a convex mirror, it is also called diverging mirror. Diverging in a sense that the reflected rays diverge after the reflection. Concave mirror, it is also called converging mirror because the reflective rays converge or intersect after the reflection. All right? Okay. In locating the images formed in curved mirror graphically, there are three important points to be considered. Okay. The center of curvature stand for letter C. the center of the sphere of which the mirror is part. For example, if that is a concave mirror, and that one is a convex mirror. So, if that line drawn at the center, that is a principal axis. So, the center of curvature is located, or it is the center of the sphere of which the mirror is part. Center of the sphere. Then, another point is the vertex. The vertex is the center of the mirror. Look at the points. And another is the focal point or the focus. The point between the center of curvature and the vertex. Okay? So again, in locating the image form in curved mirror graphically, there are three important points to be considered. Center of curvature stands for letter C. Vertex stands for letter V. Then focal point or the focus stands for letter F. Okay, so those are the three important points to remember, especially in locating the images formed in curved mirror. The best method to use in order to locate and describe the image form in a curved mirror is what we call ray diagramming. Again, ray diagramming is used in graphical method of locating the image. And there are four principal rays that can be applied for locating the images formed in concave mirror and convex mirror. We have here the P to F ray, the F to P ray, the C to C ray, and the V ray. At this time, I'm going to show the diagram of the P to F ray. Okay. P to F ray, a ray of light parallel to the principal axis, is reflected passing through the focus or focal point or stand F. Okay. So, how it looks like. Now, assuming this is a curved mirror, concave mirror, and then the line drawn at the center is a principal axis. If that is the object, and that is for point C, that one is the focal point, and that one is the vertex. So how to draw P to F ray? Okay. It is stated in P to F ray that a ray of light parallel to the principal axis. So you have to draw the incident ray. Okay, so the red color ray there is the incident ray. So the incident ray is parallel to the principal axis. As you can see, then it is reflected. So use the reflected ray, and at this time, the reflected ray should pass through the focus or the focal point. So it goes like this. Okay? The blue color ray there is the reflected ray. So that is P to F ray. Second principal ray, we have the F to P ray. It states that a ray of light passing through the focus, or F, is reflected parallel to the principal axis. So let us draw the F to P ray. Okay. For example, that is a curved mirror, concave mirror. The principal axis is the line drawn at the center. Okay, that is points for the vertex, points for the focus and point for the center of curvature. Now, how it looks like F to P ray. This time, okay, the incident ray should pass through the focus. So it goes like this. Okay, so it passed through the focus. And then the reflected ray should be parallel to the principal axis. Okay, like that. That is F to P ray. For the C to C ray. C to C ray, a ray of light passing through the center of curvature, C, reflects along its own path. Okay, curved mirror, convex, concave mirror, principal axis, and then the arrow there is the object, then point, vertex, focus, and the center of curvature. So the ray of light passing through the center of curvature. So how it looks like, how to draw that one. Okay, so the incident ray should pass through the center of curvature. So this is it, that one. And then it reflects along its own path. So to draw the reflected ray, it goes like this. Okay, so reflects along its own path. Now for the V ray, okay, V ray, a ray of light directed to the vertex, reflects at equal angle from the principal axis. So concave mirror, principal axis, vertex, the focal point, and the center of curvature. So how will you draw the incident ray? Where should the incident ray pass? So the incident ray should be directed out to the vertex. Goes like this. Okay? And then the reflected ray should reflect at equal angle of the principal axis. Alright. So now, it produces angle of incidence and angle of reflection. Okay, now, there are ray diagramming steps for four principal rays. And these rays can be applied for concave mirror and convex mirror. Okay, what are the steps? First, from the object, draw the first ray. For example, again, a concave mirror. Next, the principal axis is drawn at the center. Okay, see the focus and the vertex. If the object is ganesha. Now, first is from the tip of the object, draw the first ray, the P to F ray. So how? Okay, that one. Apply the P to F ray. So P means principal parallel to the principal axis. F means the reflected ray should pass at the focus. That one. Another. From the same point of the object, draw the second F to P ray. So the incident ray F, meaning the incident ray should pass on the focal point. Okay, like that. And P means parallel to the principal axis. Okay. Then third, C to C ray. C to C ray means, okay, again, from the same point of the object at the top, at the tip of the object. C to C. So the incident ray should pass at C. Okay. And reflects along its own path. Alright. Okay. Then V ray. V ray, the incident ray should direct to the vertex. Okay. and then reflects at equal angle. All right. Now, have you seen that the reflected rays meet or intersect after the reflection? All right. If nakita nyo na may intersection ang mga reflected rays, so dyan nyo makikita ang image. Okay? So at this time, the intersection of the four rays is the image point corresponding to the object point. Now, if you started diagramming from the tip of the arrow-shaped object, the intersection of the reflected rays is also the tip of the arrow-shaped image. Thus, you can determine completely the position and characteristics of the image. So, if the intersection, the meeting point of the reflected rays, dyan ilagay ang tip ng object. Ganito. Okay? That's it. Now, you can now determine completely the position and the characteristics of the image. So, how will you describe? As to the location, if the object is located beyond the center of curvature, therefore, the image will form or located between C and F. And the orientation of the image, okay, it is inverted, baliktad. The size is smaller than the object. And then the type is real. Why real? Real image is formed by the intersection of the real reflected rays. Itong mga reflected rays ito ay mga real na reflected rays. Kaya, ang image na ma-form is also real. Okay, so let us have another example. If the object is located between C and F, how will you describe the image form? All right. So let us apply the principal rays and the steps on ray diagramming. First, P to F. P means the incident ray should be parallel to the principal axis. Okay? And then the reflected ray should pass at the focus. Okay? Then apply the F to P ray. F to P, the incident ray should pass at the focus. And the reflected ray should be parallel to the principal axis. Okay, so at this time, no need to, or it is okay not to apply the C to C ray and the V ray. Right? So it's alright. As long as you can see that there are reflected rays that intersect. Okay. So where's the image? Okay, to draw the image, the tip of the object should be at the intersection point. So it goes like this. Alright? So how will you describe the image form? If the object is located between center of curvature and the focus. Okay. The location of the image is located beyond C. And the orientation of the image is inverted. The size of the image is large, and the type of the image form is real. Real because the image is formed at real intersected intersected reflected rays. Okay, intersect reflected rays. Next example. What if the object is located at C? How will you draw the diagram? Okay. Apply the P to F and F to P ray. Okay. So the incident ray should be parallel to the principal axis, and the reflected ray should pass at the focus. The F to P ray, the incident ray should pass at the focus, and the reflected ray should be parallel to the principal axis. So, where is the intersection? Where did the reflected rays intersect? Okay, as you can see, the reflected rays intersect at C. So, how will you draw the image? The tip of the image should touch at the intersection point. Okay, so now describe the image form. Where can you find the image? Of course, the image is located at C. The orientation is inverted. The size of the image is same size of the object. And then the type of the image is real. So, easy ra no? Next, what if the image is located at F? Meaning the image is, no, the object is located at F, at the focus. Okay, how will you draw the diagram? Again, apply the P to F and F to P. Then reflects, passing at the focus. Okay, then the incident ray should, you cannot apply the C to C and the F to P at this time. What are you going to do is proceed to the V ray. So the incident ray should direct to the V ray and reflects at equal angle. Alright. Now, try to find the image. So what you're going to do is you have to extend the reflected rays behind the mirror. Yung nasa luyo ng mirror. At the back of the mirror. Okay. And so, what have you noticed? There is an intersection point. So the reflected rays intersect behind the mirror. All right. So, how will you draw the image? Again, the tip of the image should touch at the intersection point. The tip of the image. Okay. So, that how the image looks like if the object is located at F. So how do you describe the image form? All right. So the location of the image form behind the mirror. The orientation is upright. Yeah? It is not inverted anymore. It is upright. And the size of the image is enlarged. And then the type of the image is virtual. Why virtual? Because the image is formed. The virtual image, on the other hand, does not form on a screen because a virtual image is formed by the intersection of non-real rays. So, hindi tunay na mga reflected ray. That's why it is called a virtual image. Right? Get it? Okay. What if the object is located between F and V, between the focus and the vertex? Okay, try to apply P to F. Right. And then the incident ray is parallel to the principal axis and reflects at the focus. Then apply the V ray. Okay, the incident ray directs to the vertex and reflects at equal angle. Now, try to extend the reflected rays behind the mirror. Okay. Have you seen the reflected rays intersect behind the mirror? What have you noticed? They are not intersecting. So, they did not converge at behind the mirror. So, therefore, there is no image formed when the object is located between F and V. All right, do you have any clarifications, questions? So ray diagramming is very easy and useful in locating and describing the image formed in a concave mirror. At this time, I would like you to fill in the characteristics of the image formed in concave mirror. Okay? Now, where can you find the image formed when the object is located beyond C? All right. The image is located between C and F. What would be the orientation of the image? Okay, it is inverted. How about the size? It is small and the type of the image is real. What if the object is located at C? Where can you find the image? Okay, at C. The orientation is inverted. How about the size? The same size of the object. And the type of the image is also real. What about if the object is located between C and F? Where can you find the image? The image is found beyond C. Then the orientation of the image is inverted. The size of the image is enlarged and the type of the image is real. What if the object is at F, at the focus? How will you describe the location or the characteristics of the image formed? Okay, the location of the image is behind the mirror, the orientation of the image is upright, and the size of the image is enlarged, and the type of the image is virtual. Virtual because the image formed behind the screen does not form on a real screen. Now, how about when the object is located between F and V? Where can you find the image? Actually, there is no image formed when the object is located between F and V. All right. So, do you have any questions? Clarifications? Okay. So, I guess you are fully loaded at this topic. That's the end of our session for today. Thank you for watching.